Hello and welcome to a lesson on prime factors, highest common factors and lowest common multiples. The first part of this lesson will look at writing whole numbers as prime numbers multiplied together. And the second part of the lesson will look at how to find the highest common factor and the lowest common multiple of two numbers. To start with, we'll need to know what a prime number is. A prime number is a positive integer. Now an integer is just a whole number which is divisible only by 1 and itself. So it's not a prime number if any other number divides into it. I've listed here the prime numbers less than 20. They don't stop at 20, they go on forever. But let's have a look at the small prime numbers. We start with 2. Mathematicians agree that 1 is not a prime number, so we start counting at 2. And you'll notice that 2 is the only even prime number. Why is that? Well, it's because every other even number is divisible by 2. And if it's divisible by anything except 1 and itself, it's not prime. So there are no more even primes after 2. Notice there's a 5 there. 5 is a prime number, but there are no other prime numbers ending in a 5, because numbers like 15, and 25 and 35 are all divisible by 5, and that means they're not prime. So once we get past 5, every other prime number ends in a 1, a 3, a 7 or a 9. That doesn't mean that all numbers ending in 1, 3, 7 and 9 are prime. 9 isn't, for instance, because 9 can be written as 3 times 3. Right, now let's make sure we agree that we know what the term factors and multiples mean. First of all, a factor. A is a factor of B if A divides exactly into B. Let's illustrate that with an example. What are the factors of 6? What are the numbers that divide exactly into 6? Well, 1 divides into all whole numbers. 2, 3 and 6 also divide into 6, but they're the only 4. And notice that 6 is a factor of itself. What about multiples? A is a multiple of B if B divides exactly into A. And if we illustrate this with an example, if we look at multiples of 6, it's just numbers in the 6 times table, because 6 divides into all the numbers in the 6 times table. But it doesn't stop at 30, and it doesn't stop at 60, it goes on forever. So we can't write down all the multiples of 6. We can write down as many as we like, but we can never get them all. Factors, however, yes, we can write them all down. We can check all the numbers that divide into 6. Now then, it turns out that all whole numbers greater than 1 can be written as the product of their prime factors. Now what does product mean? Product means multiply together. So this just means that numbers can be written as prime numbers multiplied together. Let's illustrate that with some examples. 10 is 2 times 5, and both 2 and 5 are prime numbers. 12 can be written as 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. And again, 2 and 3 are both prime numbers. 7 can be written as 7. It's just one prime number on its own. 30 is 2 times 3 is 6, times 5 is 30. So again, we've written 30 as a prime number 2 multiplied by a prime number 3 multiplied by a prime number 5. And that's the thrust of the first part of this lesson. We're now going to learn how to take any whole number and write it as the product of prime numbers. Example 1. We're going to write 36 as the product of its prime factors, prime numbers multiplied together. And the way we do it is we divide 36 by prime numbers, and we start with the smallest, 2. And the reason we start with 2 is because 36 is even. I know I can start with 2. So 36 divided by 2. 2 goes into 3 once, 1 left over. 2 goes into 16 8 times. So I'm now down to 18. And I look and say, can I divide by 2 again? Yes, I can, because it's still an even number. So let's divide that by 2. 2 goes into 18 9 times. Now I can't divide by 2 anymore. Can I divide by the next prime number, 3? Yes, I can. 3 goes into 9 exactly 3 times. Can I divide by 3 again? Yes, I can, because 3 goes into 3 once. And when I get to 1, I know that I'm finished. And I can write that 36 is equal to 2 times 2 times 3 times 3. We've done all that dividing, and the reverse of that is multiplying. So it's 2 times 2 times 3 times 3. Let's just check it. 2 times 2 is 4. 4 times 3 is 12. 12 times 3, well, 10 threes are 30. 2 threes are 6, so 12 threes are 36. I can also write this, if I choose to, as 2 squared multiplied by 3 squared, because 3 times 3 can be written as 3 squared and 2 times 2 can be written as 2 squared. So that's what we mean by expressing 36 as a product of its prime factors. Let's go on now and look at another example. 50. Is 50 even? Yes, it is. So I can divide it by 2. 2 goes into 5 twice, 1 left over. 2 goes into 10 5 times. Now I'm finished dividing by 2 because I haven't got an even number. Will it divide by 3? Well, one easy way to check is if you add these digits up, 2 and 5, 7. Is 7 divisible by 3? No, it's not. Well, that's a useful check for whether a number is divisible by 3. If you add the digits up and the answer is divisible by 3, then that number will be. So you can divide 25 by 3 if 5 and 2 add up to a multiple of 3, but they don't, they add up to 7. So 3 won't go into 25. What about 5? Yes, it ends in a 5, so I know I can divide it by 5. 5 goes into 25 5 times. I can divide by 5 again. 5 goes into 5 once, and that's when I know I've finished. So 50 is equal to 2 times 5 times 5, which I could also write as 50 equals 2 times 5 squared. Either of those answers are acceptable. Moving on now to example 3. 120. What are we going to divide this by? Well, it's even, so we start with 2. And if we divide 120 by 2, we get 60. It's still even, so keep dividing by 2. And I get 30. It's still even, divide by 2 again. 15. Now then, can't divide by 2. Can I divide by 3? Well, 5 add 1 is 6, and that's divisible by 3. So yes, 3 goes into 15. It goes in 5 times. Well, 3 doesn't go into 5, but I can move on to the next prime number, which is 5 itself. 5 goes into 5 once. So I can now write 120 is equal to 2 times 2 times 2 times 3 times 5. Or I can write 120 is equal to, what does 2 times 2 times 2 mean? It means 2 cubed. 2 times 2 times 2 can be written as 2 to the power 3, multiplied by 3, multiplied by 5. And again, either of those answers is acceptable. Example 4, the last of this type. 38. We can divide by 2 because it's even. 2 goes into 3 once, 1 left over. 2 goes into 18 9 times. Now, 19 is an odd number. I can't divide by 2. And it turns out that 19 is prime. There aren't any numbers divided into 19 except 1 and 19 itself. So the only thing I can divide by is 19. 19 goes into itself once, and so the answer, this one only has two factors, 38 is 2 times 19. And this would be a good time for you to pause the video and have a go at exercise A, where you can write numbers as a product of their prime factors. Right, we now come on to the second part of the lesson, where we're going to look at highest common factors and lowest common multiples. The highest common factor of two numbers. If A and B are two whole numbers, then the highest common factor of A and B is the largest number which divides exactly into both A and B. So it's the highest factor they've got in common. The lowest common multiple, if A and B are two whole numbers, then the lowest common multiple of A and B is the smallest number which A and B will divide into exactly. So it's the first number that occurs in the A times table and the B times table. Right, let's have a look at two examples. First of all, find the highest common factor and the lowest common multiple of 24 and 40. Well, the first thing we're going to do is put these numbers in their prime factors as we did in the first part of the lesson. So let's start with 24. I can divide it by 2 and I get 12. I can divide by 2 again and I get 6. I can divide by 2 again and I get 3. Now I can divide by 3 and we get to 1. So I've now got all the factors of 24, the prime factors of 24. What about 40? I can divide it by 2 and I get 20. Divide by 2 again and I get 10. Divide by 2 again and I get 5. And now I'll have to divide by 5 because 5 is a prime number. So we get down to 1. So I can now write that 24 is equal to 2 times 2 times 2 times 3. And I can write that 40 is equal to 2 times 2 times 2 times 5. Now that's just what we were doing in the first part of the lesson. Now I want to find the highest common factor. So I'm looking for factors that are common to both 24 and 40. What can we see? Well, I can see there's a 2 there, which is also in 40. I can find another 2 because there's another 2 in 40. And yet again I can find another 2 because there's a 2 in 40. So they've got those 3 factors in common. I can't choose 3 because there's no 3 in 40, and I can't choose 5 because there's no factor of 5 in 24. But the highest common factor, the HCF, is equal to 2 times 2 times 2. That's what I was able to find in both numbers. And 2 times 2 is 4, times 2 again is 8. So the highest common factor, the highest number that divides into 24 and into 40 is 8. Now I'm going to find the lowest common multiple. Well, the lowest common multiple has to have all the factors of 24 in it, because 24 has to divide into the lowest common multiple. So I'm first of all going to write down all the factors of 24. 2 times 2 times 2 times 3. But it also has to have all the factors of 40 in it. 2 is already in it, 2 is already in it, 2 is already in it, but I haven't got the 5 yet, so I'm going to have to multiply by 5. And that's what gives us the lowest common multiple. That times that times that times that is 24. I know that because they're just the factors of 24. But I now need to multiply it by 5. Let's work over here. 24 multiplied by 5. 4 5s are 20, carry the 2. 2 5s are 10 and 2 is 12. So this actually comes to 120. So the lowest common multiple is 120. That means 120 is the smallest number that 24 will divide into and 40 will divide into. Now I'm now going to show you perhaps an easier way of finding the lowest common multiple. The way we found the highest common factor there is a good way, but for lowest common multiple I can just look at the 24 times table and the 40 times table. Now you might be thinking you don't know your 24 times table, but we can work it out as we go. So I could just write down 24 is the first multiple of 24. If I add on another 24, I get 48. Add on another 24. Well, 48 add 20 is 68. Add on 4 is 72. Let's try some in the 40 times table. That's a bit easier. 40, add on 40 is 80. Add on 40 is 120. Add on 40 is 160. Haven't seen anything common yet. Let's go back to this one, build this one up. Add on 24 onto 72. Add on 20, we get 92. Add on 4, we get 96. Let's add on another 24. Well, 96 add 4 is 100. Add on 20 is 120. We can stop there. There it is. The first common multiple of 24 and 40. The first number that occurs in both the 24 times table and the 40 times table. So that's an alternative method of finding the lowest common multiple. We'll now have a look at one more example of finding the HCF and LCM, or highest common factor, lowest common multiple. 36 and 48. So first I want to break these numbers down into their prime factors. So starting with 36, it's even, so I can divide by 2. 2 goes into 3 once, 1 left over, 2 into 16, 8 times. Still even, so keep dividing by 2, and I get 9. Divide by 3 now, the next prime number that goes into it, and I get 3. Divide by 3 again, and we get 1. So I write down here 36 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. Let's work on 48 now. It's even, so I can divide by 2, we get 24. Still even, keep dividing by 2, we get 12. Even again, so divide by 2 to get 6. Still even, keep dividing by 2, we get 3. And now we'll have to divide by 3 to get down to 1. So 48 is 2 times 2 times 2 times 2 times 3. That's 4 factors of 2 and 1 of 3. And now we're going to identify the highest common factor. That's what is common to both these lists, common factors. We use circles again to identify them. There's a 2 in each of them, another 2 in each of them. I can see a 3 in 36 and a 3 in 48, but that's it. Can't get another 3 because there are no more 3's in 48. Can't get another 2 because there are no more 2's in 36. So the highest common factor is 2 times 2 times 3. Both of them have 2 times 2 times 3 in them. 2 2's are 4, times by 3 is 12. So the highest common factor is 12. That means that 12 is the biggest number that will divide into both 36 and 48. Now we're going to find the lowest common multiple. Now the lowest common multiple has to have all the factors of 36 and all the factors of 48. So let's write down the factors of 36 to start with. We'll have 2 times 2 times 3 times 3. That's all the factors of 36, those 4 there. Now I need to make sure I've got all the factors of 48, but some of them are already there. That 2 is there, that 2 is there, but there are another 2 2's that aren't there yet, so I'll have to multiply in each of those. The 3 is already there. So that will give us the lowest common multiple. Now those first 4 there multiplied to 36. They were just the factors of 36. So I've got 36 times 2, which is 72, and 72 times 2 is 144. So the LCM is 144, which means 144 is the smallest number that 36 will divide into and 48 will divide into. Again, to finish off, we'll look at doing it the same thing by looking at the 36 and 48 times tables. So 36, add on 36. 36 add 6 is 42, 42 add 30, 72. Let's add on another 36. 72 add 6 is 78, 78 add 30, 108. Right, I've got the first few numbers of the 36 times table. Let's look at the 48 times table. 48 add 48. Well, we could add 50 and take 2 off. 48 add 50 would be 98, take 2 off would be 96. Let's do that again. If we add 50 on to 96, we get 146. Take 2 off, we get 144. That's an easy way of adding on 48. Let's go back to here. Add on 36 on 108. 108 add 6 is 114. 114 add 30 is 144. And there we have it. The first number in the 36 and 48 times table is 144. And that was the same answer we got using the other method, of course. Right, that concludes our lesson on prime factors, highest common factors and lowest common multiples. If you haven't done exercise A yet, do it now, but there's also exercise B, which is based on finding the highest common factor and the lowest common multiple of various pairs of numbers.